So today we're going to look at maybe using some substitution, using other identities so that we can get one basic trig equation in there, so that we're only looking at one. Alright, so I'll ask you to stop and do this one for me. So this one is a tangent cubed x plus tangent squared x minus a 3 tangent x minus a 3 here is equal to a 0. So what does this look like? How many terms do I have right there? I have 4. So if I had 4 terms, I could do this one by grouping. So out of this first one, I can factor out a tangent squared x. And then I would be left with a tangent x plus a 1. And then out of the second one, I can factor out a negative 3 here, and I would be left with a tangent x plus a 1. And then we would have a tangent squared x minus a 3. And then you would have this tangent x. Those are the same. So it would be tangent x plus a 1 here. All right, so you would have set both is equal to a 0. So tangent squared x minus a 3 is equal to a 0. And then tangent of x plus a 1 is equal to a 0. So then this will be tangent squared x is equal to a 3. So then this would be tangent of x is going to be plus or minus square root of 3. Okay. And this one over here would just be tangent of x is equal to a negative 1. All right. So tangent of x, remember, is sine over cosine. Okay. So sine over cosine. So basically you want to find where cosine and sine, so where is sine square root of 3 over a 2, and where is cosine a 1/2. So sine is square root of 3 over 2, so that would be what? Pi over 3. And then again at where? 2 pi over 3? Because it's in the interval between 0 and pi. So it's going to be pi over 3 and 2 pi over 3. And now where is tangent of x going to be equal to a negative 1? So sine of x over cosine of x is equal to a negative 1. Okay. So that could be maybe on the unit circle, maybe on your x and y axis, or it could just be the square root of 2 over 2, right? And square root of 2 over 2. So that would be 3 pi over 4 on the unit circle. Okay. All right. So today we're going to look at using different trig functions and identities here. So we've got cosine of x minus 1 is equal to sine squared x. Well, I have two different, if I were to move this one over, then this would be a, well, let's just move all that over here and make it 0. So this would be a sine squared x minus a cosine of x plus a 1. And right there, nothing is the same. Okay, I can't factor anything, I can't take anything out, but I do know that sine squared is going to be the same thing as 1 minus a cosine squared. So sine squared is the same thing as saying 1 minus a cosine squared. Okay. All right, so now I'm going to have a negative cosine squared minus a cosine. 1 plus a 1 gives me a 2. All right, if I were to factor, let's go ahead and factor out a negative here. So I would be left with a cosine squared x plus a cosine of x minus a 2. So I need to factor, so this will be cosine of x minus something, and then cosine of x plus. So it's a negative 2, so 1's going to be a negative and 1 will be a plus. So cosine times 1 is a cosine, or cosine times cosine is a cosine squared. cosine times 1, well, this should be a positive and a negative here. Can't do basic stuff. So this will be a negative 1 plus a 2, so that's a positive 1. And then when you multiply, there we go. All right. So now we'll set both of those equal to 0. So I'll have cosine of x plus a 2 is equal to a 0. And then cosine of x minus a 1 is equal to 0. So where is cosine of x going to be equal to a negative 2? And where is cosine of x going to be equal to a 1? Cosine of x is not going to be equal to a negative 2. So where is cosine of x going to be equal to a 1? And that's going to be at 0 and 2 pi. Okay. Alrighty. So what about this one? Number 13, we've got cotangent squared of x minus a 3 cosecant of x plus a 3 is equal to a 0. Okay, well, cotangent, remember, cotangent squared x plus a 1 is going to be equal to cosecant squared x. If you could see that, it would help. There we go. So cotangent squared x plus a 1 is going to be equal to cosecant squared x. So we could rearrange this, and it could be what? Cotangent squared x is going to be equal to cosecant squared x minus a 1. So if I plug that in for cotangent, then this is going to be cosecant squared x minus a 1 minus a 3 cosecant of x plus a 3 is equal to 0. So we'll have cosecant squared x minus a 3 cosecant x plus a 2 is equal to a 0. And then now we'll factor. So this will be cosecant of x, cosecant of x. So it multiplies together to give you 2 and adds together to give you a negative. So this is going to be a negative 2 and negative 1, because they'll both have to be negative here. So we'll plug in. So we'll let cosecant of x is now going to be equal to a 2, and cosecant of x will be equal to a positive 1. Well, cosecant is the inverse, is the reciprocal of sine. So where is sine going to be equal to a 1/2? And where is sine going to be equal to a 1? So where is sine going to be equal to a 1/2? And this is in between 0 and 2 pi. So that's going to be what? Pi over 6. And what? 5 pi over 6. And where is sine going to be equal to a 1? And that's pi over 2. All right, so let's look at number 14 here. So number 14 is 3 tangent of x minus 2 square root of 3 sine of x. So I want you to try to do this one for me. Well, tangent is the same thing as sine over cosine. Well, here, what can you factor out here? You can factor out a sine of x, and you will be equal to, or left with, a 3 over cosine of x minus 2 square root of a 3. So set both of those equal to 0. So we're left with sine x, where is sine of x going to be equal to a 0? And where's 3 cosine of x going to be equal to a 2 square root of a 3? If you multiply here, So you'll have 3 over 2 square roots of 3. So where is cosine of x equal to 3 over 2 square roots of 3? So then if you multiply, rationalize this, that turns into 3. So where is cosine of x going to be equal to a square root of a 3 over a 2? And where is sine of x equal to a 0? So where is sine of x equal to a 0? And that is at 2 pi. And then where is cosine of x going to be equal to a square root of 3 over 2? So we're looking just at the interval between pi and 2 pi. So where is it going to be square root of 3 over 2? And that's going to be 11 pi over 6. All right, let's look at number 15 here. So number 15, we have secant of x minus tangent of x is equal to a 1. So secant is 1 over a cosine. And tangent is equal to sine over cosine. If you got a common denominator here, or if you move the 1 over, so this will be a 1 minus sine of x over a cosine of x is equal to a 1. So if you multiplied both sides, so you would have 1 minus sine of x is equal to a what? Cosine of x. And then what do you have? So you would have 1 minus a sine of x is equal to a cosine of an x. So for this one, it's going to be a little crazy. I'm going to need some room here, but for this one, we would need to square both sides. So I'm going to come down here. And when I square both sides, then it's going to help me a little bit with finding the x values. So here when I square, I'll have 1 minus 2 sine of x plus a sine squared x. And now I can use some identities that I know. This is going to be a cosine squared x. Well, cosine squared x is the same thing as one minus sine squared x, right? So then if I were to simplify, if I move my 1 over here, my 1's are going to go away. If I move my sine, this turns into a 2 sine squared x. And then that'll be a minus 2 sine of x. And then I can factor out a 2 and I can factor out a sine. And I will be left with a sine of x minus a 1. And then you're going to set both of those equal to a 0. So where is 2 sine of x equal to a 0? So where is sine of x equal to a 0? And where is then sine of x going to be equal to a 1? So sine of x is going to be equal to a 0. And it's going to be in the domain of 0 to 2 pi here. So it's going to be 0 and pi and then a 2 pi. And where sine of x is going to be equal to a 1, and that is going to be a pi over 2. Okay, we do need to check our solutions here and see if they work, because we did square both sides up here. So if I were to plug in pi over 2 here, so here are my solutions. Okay, so let's look right here and figure out if I plug in a 0. So sine of 0 is going to be equal to a 0. Cosine of 0 is going to be equal to a 1. So that is an okay answer. So that would mean that 2 pi is also an okay answer. So sine of pi is going to be equal to a 0. Cosine of pi is going to be equal to a -1. So that's not going to be a solution. So pi is not going to be a solution. When you have the same, the two same values inside there, you don't really have to worry about it as much checking your answers. So pi over 2, so sine of pi over 2 is a 1, so 1 minus 1 gives me a 0, and cosine of pi over 2 is a 0. So we're good. Okay. All right. So let's look at number 16. So y'all try to do number 16 for me. So if I were to subtract this over here, so this will be sine of your double angle plus 4 minus a 3, which is a cosine of x. Sine of our double angle is the same thing as saying 2 sine of x, cosine of x. Now what about this one? Can I factor something out here? I can factor a cosine. So if I take a cosine of x out, I will be left with 2 sine of x plus a 1 is equal to a 0. So then you'll have cosine of x is equal to a 0, and then 2 sine of x plus a 1 is equal to a 0. So this will be sine of x is equal to a -1/2. So where is cosine of x going to be equal to a 0? So that is going to be at pi over 2. And then 3 pi over 2. And where is sine of x going to be equal to a -1/2? So a -1/2 is going to be where? 7 pi over 6. And what? 11 pi over 6. So up here, if you plugged in your pi over 2, so if you check your answers, so sine of pi over 2 is 1, cosine of pi over 2 is a 0, so that turns into a 0, and 0, so that is true. 3 pi over 2, 0 and 0, so we're good there. 7 pi over 6, so sine of 7 pi over 6 times cosine of 7 pi over 6 plus cosine of 7 pi over 6. Alright, so if I plug this in, so sine of 7 pi over 6 is a -1/2. Cosine of 7 pi over 6 is a negative square root of 3 over a 2. You can't see that, sorry. Trying to get used to this and it's not working. Cosine of 7 pi, so that'd be a negative square root of 3 over a 2. So this, a negative times a negative turns into a positive, so this is a square root of a 3 over a 2 minus square root of a 3 over 2, which is a 0. So 7 pi over 6 is okay. And then now what about 11 pi over 6? So we'll have 2 times sine of 11 pi over 6, cosine of 11 pi over 6, plus cosine of 11 pi over 6. So Sine of 11 pi over 6 is a negative 1/2. And cosine of 11 pi over 6 is a square root of a 3 over a 2. So this will be a negative square root of a 3 over a 2 plus a square root of a 3 over a 2. And that gives you 0, which is good too. So all of those answers are going to be our solutions. Okay. All right, I want y'all to try to do number 17 and number 18 for me, finish up your homework, and then we will review Monday and have a quiz on Tuesday. All right, let me know if y'all need anything. Y'all have a good day.